So let me try and explain how I think about this problem. So these numbers are the joint distribution table, right? So each of these numbers, let's say this number here. This number represents the probability that x is equal to 2 and y is equal to 2. Right? That's what this number is. Because whatever x is here and y is here, that's what this number represents. That's the joint distribution table. Right? That is the probability the one. So now, if you let's just do a little bit of jugglery. Let's come down here a little bit. Suppose, if I want to compute the chance that x is equal to 0, let me go back to black perhaps. If I want to compute this, so how would I do that? So I would have to do, first I would look at when x is 0, what all values y can take. Y can take 0, 1 or 2. Right? So the first thing I observe is that probability x equal to 0 is the same as probability x equal to 0 and y is equal to 0, or x equal to 0 and y equal to 1, or x equal to 0 and y equal to this. And then these are all disjoint events. So let me mark them in red hue. So disjoint events. So I can add them up. So when I add them up, the probability, what I get probability x equal to 0, y equal to 0, plus the probability x equal to 0, y equal to 1, plus the probability x equal to 0 and y equal to 2. That's what I do. That means all I would do is go to the table. Let me erase these marks. That's clear what's going on. What happened? And do it. Oh, sorry. Let me do that as it is. So now the idea is that if I want this black answer, right? Let me mark this purple in purple perhaps. So if I want this purple, all I have to do is go to this table, and if I have x0, y0, x0, y1, x0, y2, all I have to do is sum up this row, right? This column. Sum of that column, I'll get the answer. So what's the answer now? The answer will be, I have 0 for y when x is 0 and y is 0, plus 1 over 12, plus 1 over 12. So I would get 2 over 12, that is 1 over 6. Is that clear? You can let me know on chat if it's clear or not. Right, very good. So let's see now y equal to 1. How would you do? Y equal to 1 the same way, right? Suppose you want probability y equal to 1. You look at what all values x can take when y is 1. You go upstairs to the table again. When y is 1, x is minus 0 or 2, right? Again, when y is 1, you know that y equal to 1, x equal to minus 1, or y equal to 1, x equal to 0, or y equal to or y equal to 1 and x equal to 1. And that's what the table tells you, right? Then y x equal to 2, sorry. Sorry about that. That means when y is 1, x can take these three values. Again, like before, these are all mutually exclusive. They're disjoint from each other. So you just add them up, right? So your probability y equal to 1 and x equal to minus 1, plus the probability y equal to 1, x equal to 0. What happened to that pen? Let me just check something happened about that. Give me a second. Y equal to 1 and x equal to 0, plus probability y equal to 1 and x equal to 2. So let me just mark this whole thing in blue so it's clear what we're trying to compute. x equal to 0 and y equal to 1, x equal to 2. So you come down here, and then what do you get? You get the chance that this is y equal to 1, x equal to minus 1 is the probability that 2 over 12 plus y equal to 1, x equal to 0 is 1 over 12 plus y equal to 1, x equal to 2 is 0. So I get 3 over 12, or which is 1/4. Very nice. So that's part 1 and part 2. How do you do part B now? Part B is asking for the conditional distribution probability of x equal to 2 given y equal to 2. Right? So how do you do that? So can someone give a hint of how to do that problem? How do you find out probability x equal to 2 given y equal to 2? What's the first step you will do? Can someone on chat just say a conditional probability? How do you do that? So by definition of conditional probability, this is the same as x equal to 2 and y equal to 2 divided by probability y equal to 2. That's what we have. Very good. So now, if I want to do probability x equal to 2, y equal to 2, I go back up again. That's just this number. X equal to y equal to 2, we know it's 1 over 12. So top is easy, is 1 over 12. And the bottom is again probability y equal to 2. Now, how to calculate y equal to 2 again? So y equal to 2 again, you look when y is 2, x can be minus 1, 0 or 2. So you come here, you say probability y equal to 2 is the same as probability y equal to 2, x equal to minus 1, or y equal to 2, x equal to 0, or y equal to 2 and x equal to minus 1, x equal to plus 2. And again, like before, these are disjoint events. Right? So you can, they're mutually exclusive, so you can add the probabilities up. So that's same as probability y equal to 2, x equal to minus 1, plus probability y equal to 2, x equal to 0, plus probability y equal to 2. And that's just how to go and add the last row. 3 over 12 plus 1 over 12 plus 1 over 12. So you just get this 3 over 12 plus 1 over 12 plus 1 over 12. That's 5 over 12. So therefore, probability x equal to 2 given y equal to 2 is now 1 over 12 divided by 5 over 12. That's just 1 over 5. Okay. So now let's just let's do the last two parts. What is the last two parts say? Part C says I have to do y equal to given x equal to 2. Right? The roots. So how does one do that now? The same way, right? Do the same way. So let me put the page here. The page, I'll be insert a page, new page after. So part C is I have to estimate probability y equal to 2 given x equal to 2. But that's the same as probability y equal to 2 and x equal to 2 divided by probability x equal to 2. Very good. So again, the same way, the top part is the same, right? Y equal to 2 and x equal to 2 is the same as the top part right here, which is 1 over 12. That part again is easy, 1 over 12. And I have to find the probability n equal to 2. But again, how do you find x equal to 2? X equal to 2, you look at when x is 2, what all y can be. When x is 2, y can be 0, 1, or 2. Right? So you go again, x equal to 2 is the probability that x equal to 2, y equal to 0, or x equal to 2, y equal to 1, or x equal to 2, y equal to 2. Very nice. So again, disjoint union, you can sum them up again. So same as the probability that x equal to 2, y equal to 0 plus probability x equal to 2, y equal to 1 plus probability x equal to 2 and y equal to 2. And this is just saying, you go back to the table again. The table tells you that you have to just add the last column. Okay? So 3 over 12, 0, 1 over 12. That means you get 3 over 12 plus 0 plus 1 over 12. So that's 4 over 12. So therefore, the probability that y equal to 2, given x equal to 2, same as 1 over 12 divided by 4 over 12, and that's just a quarter. So the conditional probability of y equal to 2 given x equal to 2 is a quarter, and that may not be the same as probability x equal to 2 given y equal to 2, because they're two different events in conditional. So a given b and b given a may not be the same. Very nice. What about D now? Is it true that x and y are independent? How do you check independence now, typically? What do you check? Are x and y independent? How do you check that? Does anybody understand how to check independence? Okay, what's the answer? Do you think independent or independent? Right. So you can check if probability x equal to 2 is same as probability x equal to 2 times y equal to 2. Let's do that. Let's check that. So probability x equal to 2. So let's check if it's as true. Probability x, sorry, what's going on? Probability x equal to 2 and y equal to 2 is what now? That's the same. We go to the table. The table tells you x is 2, y is 2 is 1 over 12. Very good from the table. What is probability x equal to 2 now? X equal to 2 from this calculation is 4/12. Probability y equal to 2 from the previous calculation in part B is 5/12. So therefore, we know that 1 over 12 is not the same as multiplying these two. 4 over 12 into 5 over 12. Right? Make this green. Let's make this green. So green had to be equal to the blue. But unfortunately, blue is 1 over 12 and green is 4 into 5 over 12. So not the same. So they're not independent. Therefore, x and y are not independent. Very nice. So let's quickly recap the problem. So that's a complete solution for the problem number 2. Okay, let you think about it. Ask me any questions you have on this. I can move to the next question, which I want to cover. So the important concept, what all we covered in this, we covered joint distribution is given by table, and the row sums are the distributions of y, and the column sums are distribution. Sorry, the row sums are distribution of x, and the column sum distribution of y. And if you sum across the columns, you get probability y equal to 0, y equal to 2, and y equal to 3. Maybe you call these row sums. I'm sorry. And call these column sums is come down the column, you get x equal to -1, probably x equal to 0, and x. So let's try this question. This is a little bit more complicated one. I asked if x and y are independent variables, both geometric distribution, probability phi, parameter p. And I give values of p, and I ask find the distribution of minimum x, y equal to x, and so on. So for A, what you do? You do the probability that minimum of x comma y is equal to 5, right? That means when x is 5, y can be 6, 7, 8, right? Right. Very good. And vice versa as well. When y is 5, x can be 6, 7, 8, right? So one of them has to be a 5, and the other one can be anything bigger than a 5, right? So how do you write this down in terms of probabilities? Think a little bit. So the same as let's see same as probability that x is equal to 5 and y is bigger than or equal to 5, right? It could be 5 also, right? So let y is strictly bigger than 5, let's say. Or like you said, the other way is x can be equal to 5 and y can also be equal to 5, right? Or the last way is when x is bigger than 5 and y is equal to 5, right? right? These are the ways in which minimum of x comma y is equal to 5, right? Is the idea clear? Very good. They're unions, right? Very good, right? This is and, comma is and otherwise union, right? Very good. Very nice. So now you just go and write this as, first you write this as probability x equal to 5, y bigger than 5, plus probability x equal to 5 and y equal to 5, plus probability x bigger than 5 and y equal to 5. Very good. So now what do you use now? This is because the events are mutually exclusive. Now you know independence, right? You know x and y are independent. Independent. So then what do? You write this as, sorry, independent. So then this becomes probability x equal to 5 times probability y bigger than 5, because they're independent events, plus probability x equal to 5 times probability y equal to 5, plus probability x bigger than 5 times probability y equal to 5, right? Because of independence. Independence means any two events concerning x and y are independent. That means probability of any event concerning x and any event concerning y is split up as the probability of the products or the product of the probabilities. So what happens now? So now all you have to do is compute these guys, right? But these guys, like someone just said now, x equal to 5 means what? That means the geometric probability, this part is easy, right? So let's go step by step. Let's compute each one of them. So probability x equal to 5, let's compute this first. So probability x equal to 5 means what? At the fifth toss, you got a head. And the first four tosses, you got tails, right? So like somebody has said, it is just p times 1 minus p to the power 4. But we know that x is geometric. So this is geometric p. That's same as blue. But we also know y is geometric p. So all this is same. This is also same, right? This is also same. It's also same. So we put probability y equal to 5 is the same as probability x equal to 5 is the same as this. So that's easy to do, right? How do you do the other part? That is, let's say probability y bigger than 5. How do you do that? Right. Let me try and see if that's okay now. Yeah, probability y bigger than 5. So what is that going to be? That's going to be equal to the probability. So y is bigger than 5 means what? Means you take the union of k equal to 6 to infinity of y equal to k, right? That's what probability y bigger than 5 means, right? So what's that going to be? That's going to be again the sum from k equal to 6 to infinity of p times 1 minus p to the k minus 1. Correct? That's what you're going to get. So what is that? Can someone tell me what the answer for this is going to be? So the p comes out and I have this geometric series from k equal to 6 to infinity of 1 minus p to the k minus 1. Right? So what is the geometric series going to give you? So the first term is k equal to 6. The first term is 1 minus p to the 5, right? And I divide by 1 minus or 1 minus p, right? That's what the geometry says. Is that correct? Right? It's b by 1 minus r, right? Do you all agree? Yes or no? Oh, no one's hearing me now all of a sudden. I'm not sure. Yes, very good. So now this gives you what now? This is equal to 1 minus p to the 5. Because this was just p, right? The bottom is just p. If you look at this, 1 minus p is just p. So this cancels off with this guy, right? Very good. So now what happens now? Y equal to 5 is this. But then notice x also geometric. So this is also the same answer. Same answer, right? This is also same answer. So let's go here. Let's go here. These both are same answers. So now you know probability x. Sorry, let me erase this. You know probability x bigger than 5 is also the same as probability y bigger than 5. Same as 1 minus p to the 1 5. So you have all the ingredients now. So now you can calculate. So now let's go back. So therefore, let's do this box here. Probability minimum of x comma y is equal to 5 is going to be what now? I multiply these two. That means I get p times 1 minus p to the fourth. That's the blue part. Times the green guy, which is 1 minus p to the fifth. Right? Let me do this. Let me erase this. Let me do it properly. So I get the blue guy. The blue guy is p times 1 minus p to the fourth times the green guy, which is 1 minus p to the fifth. Right? Very good. And this gives me another plus 2 blues. So it's p times 1 minus p to the fourth, the whole to the power 2, plus this guy gives me one green, which is 1 minus p to the fifth times p times 1 minus p to the fourth, right? So the green guy is 1 minus p to the fifth. And what was my p? My p above was, if you look at my p was 0.5, right? That's what I had. P was 0.5. I put p equal to half. So I get is equal to, everywhere I put half. So p and 1 minus p are the same. So I get 1 half to the fifth, 1 half to the first term is 1 half to the tenth, the first term. Plus here I have 1 half fifth, again 1 half to the tenth, this term, right? And here I have 1 half to the tenth again. So it's 3 by 2 to the 10th. Very good. Okay, that's the answer. Very nice. Very good. So kind of a little hard question, but I think the answer. All you have to do is individually and understand how to split the events. And once you split the events, very nice. Let's do the next question. What's the next part? Next part interesting. Minimum xy equal to x. Find that out. Let's see how we find that out. Let's see. So next question. So new page after. So all I have to do is I have to find probability x minimum xy equal to x. Just try and see how to do that. So any ideas how does one start this thing? Can someone think about it? Minimum of x comma y is equal to x. How does one start this question? So minimum x comma y equal to x means what happens? That means which is the smaller one, x or y? If I have minimum x comma y equal to x, that means y is larger than or equal to x all the time. Very good. So that means this event right here, that we have here, right? This event right here. Sorry. Let me write this in pink. This event right here in pink, right, is going to be like we discussed just now. Someone just told that. Sorry. Oh, what's going on? Let me do undo. What someone just said, that for the minimum to happen, you will have to have this equal to the probability. This guy, for this to happen, y has to be always bigger than equal to x, right? Otherwise, you don't do this, right? You never get this. Sorry about that. Right, this is what you get. So now, how do you do this now? This last part, right? So how do you do the last part now? So how do you calculate the chance that y is bigger than equal to x? That's what you calculate, right? So y is bigger than equal to x. How does one calculate that? That means whatever value x takes, y has to beat that value, right? So that means x can take whatever value. X is geometric. So x is geometric means this is a probability when x is 1, y can be anything bigger than 1, right? When x is 2, y can be bigger than 2. So it means you can take the union or all possible values x can take, that is y is k equal 1 to infinity. You can take x can be equal to k, and y has to beat x. So y has to be bigger than equal to k. Right? Is this idea clear? This part is clear? That's what this event will turn out to be, right? Right? Is that idea clear or no? That is for y to beat x. Very good. Y to beat x. Right? Y has to, whenever whatever x is, y has to be larger than that. That's what you write this down this way, right? You say y is equal to k, y x equal to k, and y has to be bigger than equal to k. Very good. So now what happens to this now? This is now, all these are mutually exclusive events, right? They're all independent events, and not independent, mutually exclusive events, and it's countable union we have here. So the same as the axiom 2 of probability, same as probability x equal to k equal 1 to infinity, probability that we just write this down, x equal to k and y is bigger than equal to k, right? Very good. Right? So which means what now? Which means again you're back to the same situation now. We know the x and y are independent, so we use independence again. To get what now? You get summation k equal to 1 to infinity. This is just a probability that x is equal to k times probability y is bigger than equal to k. Right? So now that's now let's just understand this probability now. So let's come back to this. So let me erase this. Let me just write probability x equal to k and y bigger than equal to k is going to be equal to this now. But this is the same as what now? This is same as p times 1 minus p to the power k minus 1. That's what this is. And this we figured out, right? Y bigger than equal to k was going to be equal to k minus 1, right? So it's going to be this. You can check. It's a small exercise to check that. Let's just do that. So probability y bigger than equal to k is the same as the probability that union k m equal to k to infinity of y equal to m, and that's the same as the sum from m equal to k to infinity of probability y equal to m, and that's the same as p times sum from m equal to k to infinity of 1 minus p to the k minus m minus 1, and that's just same as p times 1 minus p to the k minus 1 divided 1 minus p, and these two cancel off to get this answer, right? So this is going to be again equal to 1 minus p to the k minus 1. Very nice. So that's what this probability is. So that means this is going to be equal to p times 1 minus p to the 2k minus 2. Very nice. Now what was p in this question? P was 1/3. So you just get p equal to 1/3 will imply this probability is equal to 1/3 into 2/3 the whole to the power 2k minus 2, right? So let me just simplify that a little bit. So it's 1/3. This minus 2 is just 9 by 4. That's the minus 2 part. Right? This minus 2 part, I'll just write it as 9 by 4, right? And what is left is 2/3. 2/3 I'll write it as 2/3 to the power 2k. There's the green part. I'll make it green, let's say. So I'll think of that as 4 nines. 4 nines to the power k. Right. So that's just the whole thing. If you do algebra, it's just 3/4 times 4 nines to the power k. Very nice. That's what each of the term is. So you go back to this calculation. You need this thing, the series you need to compute. So you just get, so the probability that minimum of x comma y is equal to x is the same as the sum from k equal to 1 to infinity 3/4 times 4 nines to the power k. Agreed? That's what I get on this answer, right? That's what I get. Very nice. So what is that going to be? 3/4 comes out. The geometric series again. The first term is 4/9. The common ratio is 4/9. So what do I get? 3/4 into 4/9 divided by 5/9. Right, that's right. 9 cancels off. So 9 cancels off. The 9 cancels off with this. The 4 cancels off with this 4. So all I get is 3/5. Agreed? Yeah. Very nice. Beautiful. Cool. So what is now left in the problem? So I've done 1A, 1B. 1C and 1C and E are similar. Let's try and do D. Let's try and do D. 1C, I think you can all do. Let's try and do D. How do you do probability X bigger than 11 given X bigger than 5? How do you do that? Let's see. So or we can go in order. Let's go in order. Let's do C. Let's do C is probability X plus Y equal to 5, right? Let's come here. Let's make another page after this. Okay. So let's say what is C? C is probability of X plus Y equal to 5. See, X and Y take natural numbers. If X plus Y is equal to 5, all you can do is X can take at the most K equal to 1 to 5. That's X can take K. Then Y has to take 5 minus K. But Y can't take, if I can only go to 4 because I can have X equal to 1, Y equal to 4, or X equal to 2, Y equal to 3, X equal to 3, Y equal to 2, or X equal to 4 and Y equal to 1. That's the only way I can get 5, right? There's no other way. So it's Y equal K to 4 or 5 minus K, right? So you can think of this the same this way or in this little less fancy way. So same as sum as X equal to 1, Y equal to 4, plus probability X equal to 2, Y equal to 3, plus probability X equal to 3, Y equal to 2, plus probability X equal to 4, and Y equal to 1. Very nice. So what happens to this now? This again use independence, right? Independence. So what do you get now? This is the probability that X equal to 1 times probability Y equal to 4 plus probability X equal to 2 times probability Y equal to 3 plus probability X equal to 3 times probability Y equal to 2 plus probability X equal to 4 times probability Y equal to 1. Very nice. So what do you do this now? You multiply everything. So you get again this P. The first one is P. Everything is the same, right? Everything geometric. So P times 1 minus P to the 3, right? There's P squared. Sorry, not P squared. This is P times 1 minus P to the 2. And this P times 1 minus P, this P times 1 minus P to the squared. So third trial you get that. This P times 1 minus P squared times this P times 1 minus P, same as plus P times 1 minus P to the 3, and this P, right? So everybody is the same. So you get 1, 2, 3, 4, 5. Get 5 times P times 1 minus P to the 3. And what was P here? P was 1/8. So P was equal to 1/8. So if P equal to 1/8 will imply this is equal to 5 times 1.
So isn't it 4 times?
So 1, 2, 3, 4. Thank you. Sorry about that. I didn't count properly. It's very hot in my balcony and I'm losing track of my mind. Thank you. It's 1, 2, 3, 4, only 4 times there. So 4 times 1/8 times 7/8 to the power 3. So it's 1/2 7 cubed by 8 cubed. So
also, isn't it 4 times P square, right? P square.
Oh yeah, very true. I'm just, thank you very much. I know why I'm making a mistake. Sorry about that. Sorry. Yeah, you're right. Sorry about that. Yeah. sorry, yes, p square. Sorry about that. Yeah, sorry. 4 times 1/8. I'm trying to hurry up needlessly, and I'm so making mistakes. Sorry, 7/8 the whole. That's the answer. Very good. Thank you about that. Everything is p squared times 1 minus p cubed. So I have 1, 2, 3, 4 terms, right? So I have one term. Let me mark all the pluses in red so it's clear. 1, 3 terms, and I have the 4th term. Thank you about that. Sorry about that. So is that clear? Now it's clear, right? 4 times. Very nice. That's also very nice. Thank you. So let's do one conditioning. Let's do both conditioning problems, and then we'll go to another problem after this. So what's the next one you do? Probability x bigger than 11. I think D you all can do. Let's try E. Let's try E is good. Interesting question to try. The chance that probability y equal to 5 given x plus y equal to 15. Okay, and it just lets p be between 0 and 1. Let's see what happens to that answer. Why is it? Let's just check that. Okay. So what do you have to do? X equal to y equal to 5 given x plus y equal to 15, right? Let's do E. So like you said, that the bottom guy is probability x plus y equal to 15. That's the same as the probability that, like you said, union k equal to 1 to 14, right? Probability of x equal to k and y equal to 15 minus k, right? That's that clear? That part is clear, right? The bottom part. All right. All you have to do now is make sure what the top looks like. What does the top look like now? The top will look like x equal to x plus y is 15 and y is 5. That means what are the choices for x and y then? This is just a probability that y is equal to 5, and then when y is 5, x has no choice but being 10, right? Is that correct? You see, all of you agree with this? Okay, very good. So now all you have to do is compute these probabilities, right? So we can do it in, let me do a little fancy way. I'll just a little sophisticated way. So I'll write this as the probability that y equal to 5 and x equal to 10, right? The whole thing divided by, let me put another page after this. Sorry. Oh, sorry about that. This is y equal to 5. Okay, let me copy this down. Y equal to 5 and x equal to 10 as probability y equal to 5 times probability x equal to 10 because independence, right? So I could use independence. I can use independence. Right? And then what I have at the bottom, I'll write this as the sum from k equal to 1 to 14 of probability x equal to k and times probability y equal to 15 minus k. Right? That's easy to see. Right? Very nice. So the top part is going to be what? First y equal to 5. Let's put y equal to 5 in green. Make it in green. Okay. Let me write green. Green is p times 1 minus p to the power 4. Very good. And let's leave the x in black. That's p times 1 minus p to the power 9. Right? That's what the top part is. The bottom part, I like it as sum from k equal to 1 to 14. I'll write the x part in black again. No, oh, sorry. And the y part in green. So the y part is going to be, again, if you do the y part, that's just p times 1 minus p to the power 15 minus k minus 1. Right? That's what y part is. And the x part is just p times 1 minus p to the power k minus 1. Right? That's what it is. Right? Very nice. So all I get is k minus 1 cancels off. I get p squared times 14. Right? P squared times 13. Right? Very good. Right? Is that right? I'm making a mistake somewhere. Right. This is correct. Right. So I'll get the top. I'll get p squared times 1 minus p to the 13. The bottom I should get 15 minus 2, and this is again p squared times 1 minus p to the power 13, and I have 14 terms, right? So what's going on at the top? Oh, sorry, 1 minus p to the power 13, and I have 14 terms of them, right? The sum is 14, 14 terms of that. So answer is just 1 over 14. It's kind of funky, right? That is the chance that y equal to x plus y equal to 5 given x plus y is 15 is independent of p. So that's the beautiful part of the problem. So what have we found? We have found the chance that y equal to 5, therefore, given x plus y is 15, is independent of p. Right? Independent of p. That's the part of the problem I'd like to emphasize for you to understand. Is that clear? That's what the importance of this problem is. That is, if I fix the sum, then the conditional on the sum, y is just 1 over 14. There's no dependence on p. P can be anything you want, right? So if you take 15 tosses for x plus y for getting 2 successes, then the first success coming in fifth is just 1 over 14, any one of the 1 to 15 ones. I'll go slowly. I'll explain to you. See what happened here is, let me move this down. Sorry, let me move this down. Let me move this whole thing down. Let me move also this down. Sorry, move also this down. Sorry, this down right here, right? Leave it here. Okay, so equal to. See, what am I doing here? See that? Okay, do you see the top part is correct? Top part is what? Top part is what? One green is there, that is p. Another green is black is there, that's p squared. Is that, you see that? That's equal to p squared, right? P times p. I write this as p times p squared. And then 1 minus p to the fourth and 9, that is 1 minus p to the 4 plus 9 is 13. That's clear, right? The top part is clear.
Yes, sir. Yes.
The bottom part again is also clear, right? This k cancels off with minus k. Then I have 15 minus 1, that is 14, and I have a minus 1, that's 13. So it's 1 minus p to the power 13, and I have p and p, it's p squared, and I sum from k equal to 1 to 14. But every term is the same, right? In this expression, every term is the same. There's no difference, right? The sum has no dependence on k. So that means this is just going to be p squared at the top, 1 minus p to the 13 at the top. The bottom is p squared 1 minus 13, and you're adding it how many times? 1 to 14. So 14 times, right? That's why you cancel off. Very nice. Now let me try and see. It's already 5, 6. I want to do something from next assignment, so you all have encouragement to do that. Let's do a quick one. Number 7 in the last week assignment. It's kind of a funky assignment. I like this problem a lot. What's the answer for A? Let's do it quickly. Can someone say what is xy? Is xy Bernoulli?
Yes, it is just p square.
Xy is not p
No,
squared.
no, it is Bernoulli. Bernoulli with p square as a.
P squared. Why will it be p squared? Can someone tell me? It can't be p squared, right? See, what is xy? Let's say z is equal to xy, right? Z can take the value what? If both x and y are 1, it can take the value 1. If both x and y are, if any one 0, it will take the value 0, right? Is that correct? This part is clear, right? So this happens when what? When x is 1 and y is 1, right? When does this happen? This happens when x is 1 or y is 0, right? And it happens x is 1 and y is 0, sorry. Or what happened? Okay. And y is 0, or when x is 0 and y is 1, right? Is that clear? Is the idea clear? What value z will take? So now probability z equal to 1 is equal to what now? Is the chance that x equal to 1 and y equal to 1. That's the same as probability x equal to 1 times probability y equal to 1, and that's just pq. Right? Because x is Bernoulli p and y is Bernoulli q. Maybe you misunderstood both as p. That's probably why I said p squared. One is q and one is p. Right? Just x is Bernoulli. You can check probability z equal to 1, z equal to 0 will be the same as the reverse one. It'll just be 1 minus pq. You can write it as, it'll be p times 1 minus q plus q times, plus p, 1 minus p times 1 minus p times q. And that's just 1 minus pq, I think. Be p plus q minus otherwise I'm getting 2 pq all of a sudden. I'm making a mistake here. Did I make a mistake? Let's see. Yeah, and I also have another one. I have both equal to 0.
The third term is there.
Third term is x is equal to y equal to 0. So I have plus 1 minus p into 1 minus q. So if I do all this, I will just get P plus Q minus 2PQ. And from this, I'll get 1 minus P minus plus PQ. And what about B? Anybody has an idea of B? Is B also Bernoulli?
Yeah, it is also Bernoulli.
Yeah. What is the parameter for B? Can someone see the parameter for B? Someone said that B also is Bernoulli. W equal to X plus Y minus XY is also Bernoulli. What's the parameter? Can someone tell me? I'll allow you to check later. What's the parameter? Anybody? Check. Let's say when X is 0 and Y is 1, or X is 1 and Y is 0. Right? W is 0 in every cases, right? When X is 1, Y is 1, and when X is 0 and Y is 0. Right? Very good. Very cool. W equal to 1 is the same as the probability X equal to 0, Y equal to 1. X equal to 1 and equal to 0. And if you do this, this is just 1 minus P to Q plus P into 1. So W is what? W is Bernoulli of P plus Q minus PQ. Right? Very nice. Okay, very good. I hope I got that correct. I think I got that correct. I added this. This is very nice. Very good. No, I meant 2PQ. I think P plus Q minus 2PQ. Sorry, 2PQ. Yeah, thank you. Very nice. So let's go to assignment 6 problem. Let's come back to this in a second. So this is assignment 6.
May I ask one question?
Yeah.
It's about the multinomial distribution you discussed during this week. May I ask? Sir, am I audible?
Go ahead. Yeah.
Yeah, sir. While discussing the multinomial distribution regarding the sum of random numbers summing up to n, you said that the probability we need to find the cardinality of the set, and the cardinality of set is equivalent to the problem is equivalent to throwing n balls into k boxes, right? Now, I tried to apply to one of the problems in the assignment where 3 dice are to be rolled and the sum of the dice to be 6, right? Is there a way that we can find the values of xi's intuitively or through some kind of a mechanism?
Yeah, if it's just 3, you just do it brute force. Otherwise, you have just work out all the possibilities. There's no other.
Oh, I see.
There's no other quick fix. We
have to find out all the possibilities. Is it?
How does one do this question? How does one proceed? So let me try and write down. So what one would do is, see, x is less than y, right? So what you do is you define z to be equal to y minus x. Okay. What do you know about the range of z now? What values z will take? Can z be a negative number? Z is non-negative, right? Very good. So z is non-negative. So that means z non-negative. That means, so let's say range of Z is set of all real numbers for which Z is non-negative. That we know, right? Very nice. So then what is E of Z now? The expectation of Z, sorry, okay, something's happened to my thing. Okay, very good. The expectation of Z is equal to what now? Is the summation of Z in the range of Z, right? Z times the probability Z equal to Z, right? That's the expectation. Very good. So now we observe that all these terms Z is non-negative. So Z is non-negative. All the probabilities are all non-negative, right? So the entire sum has to be non-negative. Right? Is that clear to you? Right. Mm-hmm. That's good. Very good. Very good. Right. So E of Z is non-negative. So very good. That means what is E of Z? E of Z is, sorry, let me get the black part out. E of Z is E of X minus Y. So E of Y minus X. Sorry. So E of Z is Y minus X, and E of Y minus X has to be non-negative. Right. Right. Now, suppose E of Y was finite and E of X was finite, then E of Y minus X by linearity is the same as E of Y minus E of X. Right. So therefore, from here, let's call this a star. Right. We make this green. We make it green. Let's call this a star. So therefore, star will imply E of Y minus E of X is non-negative. So that means E of Y is always bigger than equal to E of X whenever they exist. Is the idea clear? That the means always go the same way. So in this problem, whenever the X is less than equal to X is bigger than equal to Y, Y is bigger than equal to X, the mean has to be bigger than equal to the other number. It can't go the reverse way. Very good. Okay, let's do the next problem. What did I say I want to do? How does one? Let's not do this problem. Let me do a little different problem. So this is the question in the assignments in week 6. Let me do something like, let me do f of x. Let's take f of x to be, let's say, x cubed. Instead of this problem, let's just change this problem. Okay, let's just change this. Let's just change this to x cubed. How will you do this problem? How will you find EF of x? Can someone think about it? Let me know how to do this. Has anyone weighted with the probabilities? How do you do that now? So you know this fact. You have to use this fact. EF of x. So let me not do red. Okay. Let me do blue perhaps. You know EF of x. You don't have to find the distribution of x, f of x, to find EF of x. What you do is you think of this as summation over t in t. Let's say x is from s to t. Here t is uniform. So x is uniform. So t is just -2, -1, 0, 1, and 2. So t in t, f of t times probability x equal to t. That's what EF of x is, right? That's the definition of this thing. Very nice. So what is t now? T is -2, 0, -1, 2. So it's same as f at -2. That's my f of -2 times probability x equal to -2 plus f at -1 probability x equal to -1 plus f at 0 probability x equal to 0 plus f at 1 probability x equal to 1 plus f at 2 probability x equal to 2. Right? That's what the expectation will become. Very nice. So everybody is 1/5, right? In this case, f with x cubed, like he says, already calculated to be 0. Let's try and check that. So everybody is 1/5. all the probabilities are all 1/5, right? Let's mark them all green. All the probabilities are all 1/5. So I'm going to get 1/5 times all the blues are what now? -2 cubed, like he says, plus -1 cubed, plus 0 cubed, plus 1 cubed, plus 2 cubed. They'll all cancel. This will cancel with this will cancel with this, right? So all I get is 0. Very nice. Similarly, the assignment asks f of x squared. You just do x squared. Instead of x cubed, just square the things up and do the same thing. Very nice. Let's do one more problem and I'll close for the day. How do you find covariance of xy? How does one do that? So what is covariance xy? So let me remove the red. What's the definition of covariance of x and y? Covariance of x and y is just e times xy, right? Minus ex times ey, right? Is that correct? Agreed? But what is exy now? Exy is the sum from y equal to -1, y equal to 1, and the sum from x equal to -1, x equal to 1 times xy times probability x equal to x and y equal to y minus ex and ey. We'll come back to this green part in a second. Okay, so let's do separately. Let's come to the green part. So let's do this. Let's erase this part. So exy is equal to this, right? So what's that going to be? When x is -1, y is -1, so it's -1 into -1 times the probability of this is 0.3, right? Plus this is going to be -1 into 1 into 1, the probability that is 0.2, right? Then you have -1, this you have 1, sorry, 1, let's remove this, you have 1 into -1, the probability is 0.3, plus you have 1 into 1, right? 1 into 1, the probability is 0.2. Very good. So that's E of xy. Is that clear? How do you find out E of x now? E of x is the green part. Let me write the green part. Is equal to what now? That's x can take value 1 or 0, 1 or -1, right? That's what it says. -1 and 1. So it's -1 into probability x equal to 1 plus 1 into probability x equal to 1. So x equal to -1, sorry. Right. So what happens now? What is x equal to 1? Is this number. So it's 0.3 plus -1 into 0.6. Right? That's this column. Right? How do you find this one? Plus 1 into probability x equal to 1 is this column. Right? That's 0.2 into 0.1 is 0.4. 0.2 plus 0.2 is 0.4. Right? So this whole thing is minus 0.2. The other thing you could do is E of y is same thing. Y takes value -1 and 1. So it's -1 into probability y equal to -1 plus 1 into probability y equal to 1. Right? Again, how do you find out y equal to 1? So y equal to 1, you look at this guy. This sum is 0.5. This sum is 0.5. Right? So you get -1 into 0.5 plus 1 into 0.5. So this guy is 0. Very nice. Right? So then you subtract the two, right? Just add this. What does this give you? Let's see what this gives you. This is 0.3. This is 0.3. Minus 0.2 is 0.1. Minus 0.3 is 0.3 minus 0.3 cancels off. 0.2 cancels off. This is also 0. So covariance of xy is going to be 0. Because ex times ey is 0 and exy also is 0. Very nice. So here's an interesting question I'll throw at you and I'll stop for the day. Are x and y independent? If yes, here, is it true in general? Is this true in general? is it always true? So if co-XY is it true in general? Okay. So just think about it. We can discuss it next live session perhaps. Okay. Okay, bye-bye. Have a nice week.